Greetings, Year 9 students. Welcome to our final class on Chapter 3 for right angle triangles. We're dealing with bearings today, so let's get into it. Bearings basically revolve around a compass of some kind, and the two types of bearings we're going to be talking about today are true bearings to start with, and true bearings are when you measure your angles coming from directly north, so from straight up, and always measuring around in a clockwise direction. So if you look at the compass that we have here, we'd have to use the outside layer, and you go 10 degrees, 20 degrees, 30 degrees. Remember, when you're facing due north, so we're taking, this is our starting point, and if you face north, that's 0 degrees, and as you spin around, that's 60 degrees, 70, 80, 90, 100, all the way around to 180 degrees. Keep going around, and now you've spun around 360 degrees. So that's how it works, and it must be written as a 3-digit number. Another way to measure bearings is to use compass bearings, and that's where you use either north or south first, and then you used east or west second. So for example, if I was starting here and wanted to head in this direction, I'm heading more north than I am south, so I'm heading north, and then from north you're going around 60 degrees towards the east. Or you could do something like this. You could go across, oops, let's go to there. That one there, you're heading more south than you are north. And from south, you're rotating around 10, 20, 30, 40, 50, 60, 70 degrees towards the west. So you get an idea, hopefully, of how compass bearings work. So let's try some examples. The first example, we're going to draw some true bearings. So example 1, let's draw a true bearing of 035. Sometimes you won't see the T on the end, it'll just go 035 degrees, but that's okay. And sometimes you might even see 035 degrees TN for true north. So imagine you've got your axes, there's your protractor, and we're going to start from facing north. There's facing north, that's at 0 degrees, and we're going to rotate around until we get around to 35 degrees, which means we're going to spin around to there, and that's the 35 degree true bearing written down on our page. So you can see you've got your set of axes, and from facing straight up the page you rotate 35 degrees clockwise, which means you're heading in this direction here. Let's try it again for 240 degrees. We put down our compass. Remember, you need to start by facing north at 0. So imagine facing 0, and now we have to spin around clockwise until you get around to 240 degrees, which is right around to here. So we spin all the way around 240 degrees, and we stop there, and that's the 240 degree rotation. That's your true bearing drawn on the page. Now let's go to example 2, where we're going to draw things as compass bearings, and you'll notice the questions are written differently. It'll always start with north or south, and it'll finish with east or west. Starts with north or south, finishes with east or west. So the first one, well, we still need to draw our set of axes, and remember, north and south are on the vertical axis, east and west on the horizontal axis, and some people remember it by going never eat soggy Weet-Bix. Doesn't really matter how you remember it as long as you remember it. Now, we always start from our origin here. That's the point that we begin our point or our line from, and we have to head south and then head 25 degrees from south towards the east. So if we were facing south, because it says start by facing south and now spin 25 degrees towards the east. Now to the east is to the right, so we've got to spin 25 degrees around to the right. There you have it. There's your 25 degrees, and that's south 25 degrees to the east. Let's try it again. So this one says start by facing north, which is straight up. So we start by facing north, and now we're going to rotate 30 degrees to the west, which is to the left. So we're going to rotate 10, 20, 30 degrees around to the west, which means we'll go something out like that. Around 30 degrees, and that's north 30 degrees to the west. So compass bearings. So let's do some conversions now. Example 3 says to change the following compass bearings to true bearings. So north 35 degrees to the west. Well, what would that look like? You've got to face north to start with, and then spin to the west 35 degrees. So you spin around your 35 degrees, and that would be the same as spinning if we were doing a compass bearing. Remember, compass bearings are north 35 degrees west. If we now want a true bearing, we need to face north and we need to spin around clockwise. Now, how far would we spin around degrees-wise? Well, you know a full revolution is 360, so a shortcut would be 360 minus 35, but you can also look at the protractor, spinning around 90, 180, 270, and we go all the way around to 325, halfway between 320 and 330 there, which means that as a true bearing, north 35 degrees west is 325 degrees T. Let's try that again for south 5 degrees west. So south means we've got to start by facing south, and then we spin 5 degrees to the west. So let's face south. Head 5 degrees to the west. As a true bearing, remember true bearings come off north. How far clockwise have we spun around? Well, 180 is a full half turn, and then we went another 5 degrees past, didn't we? Because we went 5 degrees past, so it would be 185 degrees from true north. So that's converted from compass bearings into true bearings. Let's try going from true bearings to compass bearings. So 200 degrees true. Easiest way is to always draw a picture. Remember, 200 degrees true, you always start facing north, and then you rotate clockwise around 200 degrees, and there it is. So there's your 200 degrees true north. Now, as a compass bearing, we're heading more south than we are north, so it's going to start with south, and from the south axis, we've head around 10, 20 degrees. So we face south and then head 20 degrees towards the west side, so it's south 20 degrees west. Let's try the next one. If you were going to start by doing 120 degrees from true north. There's true north. Let's spin around 120 degrees. We're around to here. So there it is there. What's that as a compass bearing? Well, are we heading more north or more south? Well, we're on the underside of my horizontal line, so we're heading more south. And then from the south axis, 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees back. So it's south, 60 degrees back towards the east. And that makes sense because the 60 and the 120 add up to give 180, which is a full half turn. So there we have converting from true bearings to compass bearings. Now let's look at a diagram that's already provided. And this question says to give the bearing, from the diagram, to give the bearing of A coming from O. That means you're starting at O, heading towards A. Well, what's the bearing? So if it's coming from O, that means O is our starting point. And if you could imagine facing north, then we have to spin around clockwise 150 degrees worth. So to do that particular question, as a true bearing, it's 150 degrees. Now, you could put 150 degrees T, or you could just leave it as 150 degrees, that's fine. Now let's talk about part B, which says to give the bearing of O coming from A. If we're coming from A, I now need to imagine that we're coming from A, so I need to imagine I've got my set of axes here at A. And remember, when you're heading straight up, that's 0 degrees. So we're going to turn around, go a quarter turn, there's 90 degrees. There's 180 degrees, 3/4 is 270 degrees. And I've got to come this bit here. Now what is that bit there? Well, there are different ways you can find it. I could look at this question and go, that there is going to be 30, and I know that because there's 30, there's 150, and they add up to 180, and a north-south line has to have a 180 degree angle on it. That's a right angle. If that's 90 and that's 30, 90 plus 30 is 120. And I need another 60 to get that angle there, because the three angles inside a triangle add up to 90 degrees. Now that's one way I could look at it, and then I could go from this one here. If I was facing north and I rotated around to there, well, I've gone 90 degrees, another 90 degrees, another 90 degrees, 3 90s, 270, plus 60, 330 degrees. And so that's the angle, or the bearing, of O coming from A. I need to redraw my axes that I'm measuring from when I'm coming from A. Now this question says a ship sails 60 kilometres in a direction of 42 degrees from true north. How far east of the starting point is it? Well, let's get a diagram. First of all, I need my compass. Now if I'm going to head 60 kilometres in a direction of 42 degrees from true north, remember, true north is 0 degrees straight up the page. From here I need to spin around 42 degrees. We start here, and I might go out like that, and that's 42 degrees that I spun around, and the distance along that is 60 kilometres. Now the question says, how far east am I of my starting point? Now it doesn't matter whether I draw a triangle going like this, there's a right angle triangle, or like this. Both methods will work, but I'm going to go for the triangle like this because then I've got the 42 degree angle already included. So I'm going to put my triangle going up here and then going across there. That's a right angle triangle, and now I have a right angle triangle. I know my angle, I know my 60 kilometre side, and it says how far east. Now east lies on the horizontal line, so when it says how far east, because east is on the horizontal line, in my triangle it means find the horizontal distance. And now I have enough information to answer this question, because for my 42 degrees, the opposite side is x, and the hypotenuse is 60 kilometres, and opposite and hypotenuse, SOHCAHTOA, opposite and hypotenuse mean this is a sine question. So let's answer this question. We'd start by saying sine theta equals opposite over hypotenuse. The sine of 42 degrees equals x over 60. Now because there's a number on the bottom, I'm going to times both sides by 60, which means I get x equals, they cancelled out, 60 times the sine of 42 degrees. Now it's a case of putting that into your calculator. So 60 times the sine of 42 degrees is equal to 40.1 if I take it to one decimal place, and it would be kilometres. So how far east of the starting point is my ship? It's 40.1 kilometres to the east. So let's try example 7. Example 7 says a sailing boat starts from a point O and sails 52 kilometres on a bearing of 155 degrees to point P. And then it asks how far to the east again is it? Well, let's get our diagram drawn first. And in order to draw the diagram, the first thing I need to do is get myself a set of axes. And there is my starting point. My starting point is O. And I know that because it says a sailing boat starts from point O. Now it's going to sail for 52 kilometres on a bearing of 155. Now remember, you would normally face north, and that's 0. Going around 155 degrees, if you keep spinning around, there's 90 degrees. We don't want to go as far as 180. So it's going to be something like this. Here we go. And that has spun around 155 degrees. Now, because I know that a straight line has an angle of 180 degrees, 180 take away 55 is 25 degrees. And so now I could draw myself a right angle triangle again. And let's draw it in here. The key thing is that you must include your starting point and your finishing point, which is at P. And there's my right angle triangle. And the question says how far east. Remember, east, we have north, we have west, we have east, and down here we have south. East is on the horizontal line, so I go for the horizontal line here, which means I'm trying to find that distance there. If I look at the triangle, I can also label 52 kilometres as the distance that the ship or the sailing boat travels, because it says in the question it sails 52 kilometres on the bearing of 155 degrees to point P. Looking at that triangle, there's my angle, that's the opposite side, and that's the hypotenuse. Opposite and hypotenuse, O and H. This would make it a sine question. So the sine of 25 degrees equals opposite over hypotenuse. And now I'm going to times both sides by 52, which leaves me with x equals 52 times the sine of 25 degrees. So x equals 52 times sine 25 on my calculator, 21.97. This is what the calculator says, 97614,961. And the question says to give the answer to the nearest kilometre. Well, 21.97, etc. is going to be closest to 22 kilometres to the nearest kilometre. Now, the next part, a bit trickier, says to find the bearing of O coming from P. If it's coming from P, I need to now treat P as my starting point, and I'm going to have to draw a whole new set of axes here. So imagine my new set of axes for north, south, east and west. When I've got this, it's really important that you can see, to save a bit of time, alternate angles. There's a Z shape going there. So if you look carefully, you'll see a Z shape going, which means because that's 25 degrees, this is 25 degrees. Now I know a full rotation is 360 degrees. So 360 degrees, take away the 25 degrees, means my bearing is going to be 335 degrees from true north, or just 335 degrees. So there is your answer for part B. Now it's time for you to try doing some of these questions. Enjoy the experience and have a wonderful, wonderful time.